So I made a terrible mistake. I accidentally closed um, my desktop recording program before it had finished compressing the video, and so it only made half the video. So I was talking about Michael's work, and I think I had just said something about using the set to get the distinct words. Is that right here? Or maybe using the dictionary to count the frequencies of the different words that happen in the file, which happens right here. And this is where the output happens. So let's run it, and it's runnable. This thing in the background, my transparent window is driving me crazy. What does it say? Oh, yeah, I think maybe I messed that up. Sorry, Michael. There's appears to be some weird character here. I can't delete it, but anyway, this works fine. So type in some words and hit Control D. And oh, I forgot to give the command line argument, which is, let's say, 2. And so type some things like this and hit Control D, and it gives accurately the words S, D, and S, which are the most commonly occurring words in that gibberish. And let's go on to David's. Is that right? Yeah, so David's solution is super cool. Let me just show you to make it clear. Let's just use it. So we'll do word freq.py, and you can see that it tells you how to use itself, and it's very robust. It's very resistant to monkeying around, which is really good property for code to have, especially if you're doing it professionally and your boss is going to yell at you if the program breaks or makes your business buy something that it didn't want to buy or just crashes. And so you can see he's got all these options. He has options to take words from standard in and also words from a file. So let's use it a little bit. So I'll echo some gibberish. La 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 la. And I will pipe it into his program. There it is. And now it does what it's supposed to. It says that, I guess in my gibberish nothing ever occurred twice. So there's lots of ties for the most frequently occurring word. And let's go in and see some details. So he imports these modules. This argparse one is one that I was not familiar with until I looked at this assignment, and it's very nice. It's what gives that nice output that we were looking at. Here is sort of the meat of it, where the Python is concerned. This is nicely factored, just like Michael's code. This is the place that, this is the function that scrubs the punctuation and makes everything lowercase, and here you actually count the frequencies. Oh, the frequencies are already counted here. This gives the top N. And what does this do? For pair in words, if word in pair. I think this is some auxiliary function that you can use if you want to. And here's the stuff with the argparse module, and it actually looks pretty complicated. I did check it on the web, and I skimmed the docs. I still don't completely understand how it works, but it's neat. And so here, this code even checks to make sure that if the person gives a file name, it's a legitimate file. So it's always possible that somebody would try to use the file option and then use the name of a file that doesn't actually exist, so that the program even checks for that. And wow, look at this, is ATTY. That's cool to see if it actually is from standard in. I did not know about that function. And right, so here's the sorted list. Get the top. Oh, here's where get word count gets called. If a word was supplied in the command line, get the word count that way. Okay, so very good job. And let's look at Sam's. Oh, somebody's at my door. Can I pause this thing? I think so. I'm going to pause it. So let me open Sam's code, which is called 3. How about 3.py, Sam? In fact, I'm going to do that so that it turns on my syntax highlighting. And okay, so Sam's code is incredibly short and elegant. One reason, or I guess the main reason, is, well, for one thing, he's using regular expressions, which is neat. So for here, the data just comes from reading the standard input, and for word and data, what's in data, since you use read lines, I would think of it as being lines, but I know that your code works. So let's see. So strip the words.extend. What is the list? What does extend do to a list? Does that sort of take it out of the list? That would make sense. All right. So hold on one sec. Okay, sorry. I guess I'm getting kind of tired. I've already recorded this several times and said exactly these words before, and it's kind of, bumming me out. Extend is like append, except it concatenates two lists. So you can extend a list by an entirely new list, and that's what's happening here. So words is defined up here. I was getting it confused with word. But it extends it by including this new list, which is all instances of things that match this pattern. And this pattern, this R, is saying that this is raw input, and so you don't have to use any escapes or anything in a string when you use that. And this is a letter or word, I guess a word. Anyway, so what does W stand for in regular expression? Hold on one sec. Yes, W stands for a word character, which is an alphanumeric. So it's some kind of alphanumeric one or more times, and for all instances of those get added to the words. Nice. And now bank is an empty dictionary, and this is very smart. This is a very compact way of doing this. So Sam uses the built-in list method called count, which can tell you how many times a given entry occurs in a list, and so he doesn't have to manually count them up with a counter, which is one reason that this is so short. And now he gets in this last line, this is very nice list comprehension. He gets the word with the highest frequency, but doesn't sort them in terms of frequency. But that's okay. So let's use it. So we'll do Python 3, and now we'll enter some stuff from, I'm just kind of curious what happens to the punctuation. So we'll put some of that in, and okay, and Control D. And the letter that occurs most frequently is S. And so I'm going to send out this file, and you can play with Sam's techniques yourself, and with some printouts get a clear idea of what's going on with those regex things, those regular expression things, if you want to. And this is Yada's, and Yada did a nice job too. Oh, sorry, I'm in the wrong folder. That doesn't help much either. So just one sec. Let's go back to 708 and students, and yada, and week 3. And now let's take a look at the code. Alright, so get the data from standard in, and this is the dictionary that's going to record the frequencies. So for each line in the data, for each word in the line, if it's already represented in the dictionary, then increment the count by 1. If it hasn't been included in the dictionary yet, then start the count at 1. And this is the command that sorts the dictionary by value. And this prints the word frequencies, so very nice, works just great. And let's run it once. And now I'll say some things, J, 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 and Control D. Okay, and I like this output. It gives the frequency and the word, and it's even in the right order. And it prints out the whole frequency table. So Yada declined to do the thing that prints out the 5 most frequent words or whatever. It's okay. It's all great. So I'm going to mail out a zip of all these files, and sorry that this annotation is occurring in 2 parts.